Thank you very much for the introduction. And well, this, also would like to give you an update on what we are doing here. The team is very much the same on the solar radiation. We changed our acronym, our numbers. What you used to have 72 is now 73. This is really a major change for all our documents and so on. And we have a better change in the role of FMI, where some activities move to the validation group. So what in earlier times, we were reporting about UV forecast evaluation that you won't see from my side anymore. That's in other team now, but we have FMI still as an expert in radiative transfer in our team, and yeah, the rest remains. So this slide you also know, there's perhaps just this basic information. We couple geostationary satellite information for clouds with all the IFS outputs to get time series on request processing on global direct diffuse radiation with clear sky and cloudy conditions. We are currently very close, hopefully, to have the most recent version, the publication ready. And this is also a well-known slide. Left-hand side, some key parameters of our time series on the fly processing data access, which was integrated in the ADS in the last contract, and we are now very close to bring the first gridded data sets, which are kind of pre-calculated data with a fixed software version, with a fixed spatial and temporal resolution, which is more or less our own decision, what we feel meaningful for our users. Could be any other spatial or temporal resolution. We just decide for one and make a pre-calculated gridded data set, and we'll bring that also now very soon into the ADS. We rather recently updated to the next version. Version 4 is now the operational one, which really went to, starting from calibration of our instrument, that was really a major change, also bringing a lot of advantages in accuracy. Having a new cloud scheme incorporated, really going for optical thickness to the very thin clouds, which was not done by the cloud community before, but we needed. Dealing with circumsolar radiation. So all these changes really brought a dramatic change in accuracy gain. We still have a retrained bias correction, but we will see a bit more information on that. Now having this new version operational, we start looking into that more on a detailed level. And we have quite some good experience in several research projects to look into the validation of irradiances as a function of variability of irradiances. So practically by that we split from the ground observation in radiation into different cloud regimes or aerosol regimes. So we don't have any a priori information on aerosol and cloud state, but implicitly from the ground observation and radiation, of course we guess and we grab that because physics make this classification. So we use about 8 variability classes from direct radiation, which you see here roughly illustrated. No variability at all, of course that's cloud-free, like clouds around thin zeros or aerosols. Highly variable conditions, and at the end, number 8, that's an overcast situation, like probably today. No direct radiation seen anymore. And if we split into these classes, this is a very busy plot. Don't try to understand it now with a few seconds, but this is kind of stations, and this is these variability classes. And the message I want you to take, that's relative bias and direct radiation, this flipping, look over here, these are the cloud-free class, and these are the overcast class. And you see kind of flipping in the bias structure. And if you go into detail, you see many more details. So what we actually found in many activities that we have a balancing out, especially in the biases between the aerosol or more the cloud regimes. And of course, we don't like this kind of approach, but we have not seen it previously in the overall statistics so clearly. So now we can monitor separately what we improve in the aerosol and in the cloud part. That was the goal of this activity. We see from the colors here, from orange to red, improvement in the recent version. But we also see in the meanwhile that what we used to apply as a bias corrections was kind of profiting, of course, from this balancing out of errors, but as said, it's not what we want to do. So we will now remove this bias scheme in the next version. Then we worked on the CAMS reanalysis as an alternative to replace the MAC reanalysis and the MAC near real time, which are still in our data sets from earlier times. Just imagine we're always processing back to 2004. first year of Meteosat second generation data. So if the user requests 2004 to 2006, we process it on request. That's why we have MAC reanalysis and all the old data sets in here. And so we investigated the CAMS reanalysis, and you see nicely what is negative here is a gain, so a reduction in biases or RMSE. And you see, well, we are losing this gain over time, so obviously the IFS is doing better over time. Ooh, good. Or this is more for the desert stations in Northern Africa or around the world, which are focus. This is over all stations. What is bluish is good, and if the blue disappears a bit, that means that the IFS is doing quite well. CAMS reanalysis is not doing always better anymore at the end here, but for the long period, it's really worth doing so, and we will switch to the CAMS reanalysis now. So this will be the next version, 4.5, in a few weeks from now, will be operational. Another major step we are going at the moment, look on this side, you see now 2 geostationary satellites. We are working a lot on Himawari 8 data, downloading it, real-time chain is running in test mode, the offline processing data, thanks to the Australian Bureau, we have access to full resolution data, and we're currently integrating that and doing reprocessing, and so at some time we will be able to provide the processing on this larger geographical coverage. Larger geographical coverage, that means a lot of extra effort on the other side here. You may, well, first let's have here, if we go to the Himawari area, we need, of course, to go also to the validation data, obtain this routinely and include that in our quarterly validation. But we also have for quite a while a global product, which is actually the Clear Sky product, which we never validated separately, which of course is not what we want to do in CAMS, so we started doing that. So we extend step by step, or station by station, to a global scale validation of the Clear Sky service product. Another service to users is a multi-annual, very busy plot for experts, very informative, which we included now regularly in the validation report. And this is an experiment assessment for the new cycle, where we see on the left-hand side biases, on the right-hand side RMSEs, and perhaps if you look into the last column and let's say blue is better and red is worse. And on the lowest part you have the average over all stations. So for RMSEs, a lot of stations performing much better. We met these situations. It's a lot of dusty regions here as well. For the individual stations in terms of bias, it's pros and cons. Overall, it's a very small change. So from our perspective, it's okay to go for the next cycle, also from the irradiance evaluation. And yeah, of course, there's a lot to think for the dust people and the aerosol modelers and look into detail, which is part of the exercise. Then we have a very, very nice collaboration. We actually have a lot of positive benefit from a collaboration in the International Energy Agency, in the PVPS program, that's the Photovoltaics Power Systems program. A lot of enthusiastic scientists, I would say, and the national funding here from a project in Germany managed to grab a lot of historic data all together in all around the world, which is a strong improvement, not for, let's say, online validation activities, but for historic assessments. And we are supporting that to maintain this database, to bring it a bit into a sustainable status, and with some additional tools on quality control, and of course that helps us very much as well. Okay. For example, this is the amount of large different data sets. We are normally using mainly BSRN and the INAMENA stations, but we have many more around the world. This is all coupled into an IT infrastructure where we have an automatic access, automatic scripting, and all that what we, in our community in solar energy research, we dreamt for quite a while, and this has now become a reality. A few more plans. As I mentioned, Himawari 8 major reprocessing is ongoing. That will last quite some months, as it's some data to be transferred from Australia to us. I mentioned the ADS integration of the first gridded data sets. we actually also work on something what we call a critical case database. Imagine if we do 1 year of all data processing, there's a lot of different cases, and we may be interested in a typical cloud structure to improve that in our retrieval. These are very few cases in a large set of statistics, so we need to figure that out and work on dedicated smaller test data sets. I have a bit in mind for some people the Tiger data set or these kind of data sets we used in vertical profile development years ago. This is a bit the heritage here, to set up this for our purpose, and we call it a critical case database. Yeah, then we're working on a next ClearSky model version, which should couple more directly to the direct model output of the IFS. We currently perform a mapping to the well-known, but also very old-fashioned and known to be not very accurate, opaque aerosol types. We would like to replace that by direct usage of the optical properties for the aerosols out of the model. And yeah, we just spent here also a day to discuss this again in detail, and I think Sam will be the rapporteur in a few minutes to talk a bit what that means for us. Yeah, 2 other activities to evaluate the radiance forecast of the IFS will start. And we have Metisat 3rd generation, the new imager capabilities coming up, of course. Yeah, that's something we need to change at some time. Yeah, so we're preparing for that. And let's see, I think this is the housekeeping slide with references and contact details and so on. So I try to be short, not getting all the details, as we are really late. So I hope you'll like that and have a bit the idea what to talk about a beer this evening with me, the team, which is always there around.
Okay, thank you very much. Questions? Yes, one. There.
Yes, a quick one, promised. Do you have plans in integrating the ozone measurements that are coming from the GEMS Korean satellite and will come from geostationary Sentinel-4? And if yes, how? How do you see this?
I would like to forward that question to the SMWF, because we take the IFS output, the ozone field, and if it's in there, then it's in there, and if not, then no. It's nothing we do actively with all the, yeah. So who can answer if it's an input to the IFS in now or in future? Johannes?
I mean, these satellites, of course, they will be assimilated once they are available. The focus is probably more on air quality than on total column ozone, because the area is so restricted. But yeah.
First, we need to have access to the GEMS data. The big interest is on NO2, really initially. So I think so. We have potential use of GEMS as part of the proposal, which has been submitted to the Commission as CAM service evolution. I don't think, yes, total ozone will be a key priority, but if the product is good, and that could be done. But it's not. Yeah, the focus with GEMS is more on NO2, but we don't have the data for now. So.
Thank you. Any other questions?